Hello, this is Dr. Heath and welcome to Intermediate Algebra. We are starting off with Chapter 3, Graphs, Linear Equations, and Functions. Before we get started, make sure you print out the corresponding lesson pages so that you can follow along and take notes and work through the exercises. Our objectives in the first section of the rectangular coordinate system are to interpret a line graph, plot ordered pairs, find ordered pairs that satisfy a given equation, graph lines, find x and y intercepts, and recognize equations of horizontal and vertical lines and lines passing through the origin. We'll begin with a discussion of the rectangular coordinate system. This is also called the Cartesian coordinate system, named after the famous mathematician René Descartes. The coordinate system is basically a piece of graph paper that is divided up by the two axes. We have the x-axis, that is the horizontal axis ranging from the left of the page, which is negative infinity, all the way to the right side of the page, approaching positive infinity. Then we have the y-axis. That's our vertical axis that runs up and down the page, where down the page is negative infinity and up the page is positive infinity. Those two axes intersect at the origin. Now, the origin is the point that we locate right in the middle, and each point on a piece of graph paper or the Cartesian coordinate system can be found with a location of coordinates x comma y, where x is your horizontal position, either left or right, and y is your vertical position, either up or down from the origin. So the origin itself has coordinates of 0, comma 0. Any point that's can be found by graphing its corresponding x and y value. For example, the point 2, comma 3 is found by going 2 units to the right of the origin and 3 units up. So the corresponding point would be right there. The x and y axis also break up the graph paper into quadrants. And we label these 4 quadrants with Roman numerals. Quadrants 1, 2, 3, and quadrant 4. Quadrant 1 is where x and y are both positive. So we label this as quadrant 1. And every single point that's located in quadrant 1 will have both positive values for x and for y. And we're going to continue the quadrants, numbering them counterclockwise. So in this location here, this is quadrant 2. In this quadrant, the x value is negative and the y value is positive. In the next quadrant, quadrant 3, the x value is negative and the y value is negative. And then finally, the last quadrant here is quadrant 4. In this quadrant, the x values are positive and the y values are negative. So every point on a piece of graph paper can be found either on the x or y axis or in one of those quadrants. Now, an equation actually describes a graph that can be displayed on a piece of graph paper. For example, here we want to complete each ordered pair for the equation 3x plus 4y equals 7. This is an example of a linear function, and my pen is a little shaky there, but a linear function is a line on a piece of graph paper. But the way that we find the specific points on the line are by plotting ordered pairs. So for our first example, part A, here we're given 5 comma question mark. In other words, our x value is equal to 5, x value is equal to 5, the y value is unknown. To find that corresponding y value, we're going to plug it in to the equation. Wherever we see the x, we're going to replace it with 5. So our equation is 3x plus 4y equals 7, and we're going to substitute in 5 where we see the x. So it's 3 times 5 plus 4y equals 7. Now I'm going to simplify and solve this equation by first multiplying 3 times 5 to get 15 plus 4y equals 7. Then I'm going to subtract 15 from both sides to get 4y equals negative 8. Okay, and I subtract 15 from both sides. 7 minus 15 is negative 8. And then I would divide by 4, sorry. Divide both sides by 4. 4 times y equals negative 8. So I divide by 4 to get y equals negative 2. So that's the corresponding y value when x is equal to 5. So we can name that, we can say that that point that corresponds is 5 comma negative 2. All right, now let's look at part B. In part B, the x value has a question mark and the y value is negative 5. So we want to find x, that's our unknown, when the corresponding y value is negative 5. Again, what I'm going to do is take my original equation, which is 3x plus 4y equals 7, and I'm going to replace the y value with negative 5. And notice when I do the substitution here, I put parentheses, and that just helps me keep track of um, positives and negatives. Now I'm going to simplify this equation by multiplying 4 times negative 5 to get minus 20. And then I'm going to add 20 to both sides to get 3x equals 27. And then divide both sides by 3 to get x equals 9. So the corresponding point, the x value is 9 when the y value is negative 5. Now these 2 points fall on the same exact line. So we could graph these. Oops. Here we have our graph paper. This is just a rough sketch here. Our x-axis, our y-axis. We'll locate the point 5, negative 2 by moving over 5 units. 1, 2, 3, 4, 5, and down 2 units. And that is your first point. And then your other point is 9, negative 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then down 1, 2, 3, 4, 5. And then my line is going to go through those 2 points. Now bear with me here because the stylus I'm using is giving me a little bit of a jiggly graph here, but it is a nice straight line when you graph it. I recommend using graph paper and a ruler so you get a nice straight line.